Hello, in this lesson, I'm going to review chapter 7, 1. For chapter 7, I'm going to do a series of review video. This is the first one. Okay, first, let's talk about why do we use mu equal to 0 and standard deviation equal to 1 for a standard normal curve, right? So let's consider the example. Erica was excited that she received 60 on her physics test, while Jen was so upset that she received 60 on a French test. Now, but if they both had the same, score, why does it matter? Well, let's say both of the courses had test data that follow a normal curve. If the physics test had a mean of 65 and a standard deviation of 5, while the French test had a mean of 65 and standard deviation of 2. How can we compare these two students' success? Well, if we convert both of those scores to a standard normal, we can compare them easily. Note that they both are normal with a different mean and standard deviation. So step 1, we're going to convert them to using the same normal curve, which calls standard normal. Now to convert them, we use convert x to z, and we call that the conversion formula is equal to x minus mu over standard deviation, for example. So x minus mu over standard deviation. And that would be one of them, right? So we can use that formula to convert them to normal 0, 1. So standard normal is normal 0, 1. Notice that it's here, standard normal 1. And we usually write it as normal mu equal to 0, standard deviation equal to 1. That's standard normal. We can write down the information for both Erica and Jen in the same manner. I can say Erica, this class average follow normal distribution of mu 65, standard deviation of 5, where Jen also have classes have a mu of 65 and standard deviation of 2. So before we convert, do the problem, we want to write them down so that way it's really easier to check. So now let's convert them both into a z. So z for Erica, x minus mu over standard deviation. Once I convert Erica, so I'll say x minus mu over standard deviation. So that's 60 minus 65 over 5, we got negative 1. Where Jen, we converted, we got negative 2.5. Note that they both score below the average, but let's draw on a normal curve, see what it exactly mean. Now standard normal had a mean of 0, standard deviation 1. So this is a 0. Standard deviation 1, sigma is equal to 1. So it go down like 1, this is 2. You can go down to 3, where this is negative 1, negative 2, negative 3. Let's kind of show both the score. So Erica's score is negative 1, so Erica scores right here. Right? So where Jen's score, negative 2.5, which is somewhere here. Note that they both score below average, where note that Erica's score is on the right of Jen's score. So Erica still scored within 60%, within 1 standard deviation of the mean. We call that, according to the empirical rule, 1 standard deviation mean that's 68% of the class. Remember, we said this is total is 68% of the class, where Jen is scored outside of the 95% of the class. Now 95%, recall that is from here's the 2 standard deviation of the mean, that is 95%. So now we said Erica scored within 68% of the class, a middle 68, where Jen scored outside of the 95% of the class, so Jen's score is much lower. So here, z-score allow us to compare 2 different normal distributions and easily here by convert them to z-score. Let's do one more example. Example 2. The average for the statistic exam was 75 and the standard deviation was A. Andrew was told by the instructor that he scored 1.5 standard deviation below the mean. What was Andrew's exam score? Okay, here we want to find out the actual score for Andrew. We know the mean and standard deviation. And we also know the z-score for Andrew's score. So let's write down the information. So we say, we know that it's normally distributed. We say n, normal. The distribution for the scores, normal, with mean of 75 and standard deviation of 8. And we're given that the z-score for Andrew is Z is equal to 1.5. The question asked me for Andrew's score. Again, Andrew's score is one of the scores in the class. Oh, let me rewrite that one. Sigma equal to A. It's one of the score in the class, so X is equal to what we're trying to find out. Andrew's exam score, right? So we know that we know that the conversion formula for Z is given by X minus mu over standard deviation. Well, we want to solve for X, right? So let's solve for X here. To solve for X, I could multiply both sides by sigma. So I would say Z sigma is equal to X minus mu. Again, solve for X again. I want to make X by itself on one side. That's what I mean. I'm going to add mu to both sides. So Z sigma plus mu is going to equal to X. That's why the formula to solve for an X is equal to Z sigma plus mu. So X equal to Z sigma plus mu. So note that it's the same formula. I just rewrite it in a different form. Right? So this allows us to, let me box it. This allows us to solve for a score. Right? So using the formula, now I'm going to do it. So X is equal to Z, in this case 1.5, and sigma is A, plus mu is 75. For this, we'll get 63. That means Andrew scored 63, and to get a better understanding of where Andrew's score is, so this is standard normal 0 with standard deviation sigma equal to 1. So I say, so Andrew score 1.5, standard deviation about the mean. That means somewhere, like if this is 1, 2, that means Andrew score is 1.5 about the mean. That Andrew is right here, right? So Andrew's score here. So notice that by looking at this, I know Andrew's score pretty well compared to class. Now, when we work with the normal distribution, there's generally two things that we're looking for. We're either looking for probability or area under the standard normal curve, or we're looking for a z-score, right? Some sort of score. So let's break it apart first. Let's go over how to find area or probability using a calculator. So to use your calculator, notice that we want the first thing is go to your calculator, go to of second vars and look for distribution. That's step 1. Step 2, enter your calculator. Notice that we're using normal CDF. And when you put your enter here, you're going to put into the lower bound, upper bound, mean standard deviation, right? So if for standard normal, mean standard deviation is always 0, 1. So for standard normal, notice that in here, you always have 0, 1. If it's standard normal. For standard normal, right? So let's do some cases of standard normal. Okay, so there's 3 possible scenarios. We either look for area between two numbers on a normal curve. Normal curve, it means 0, standard deviation 1. Notice that this is standard normal z. Here, we're looking for standard normal. Or we're looking for area on the left tail of z, left of z, between two value, or on the right of z. So to use a calculator for standard normal, here we know mean is 0, standard deviation found for z. So we're going to enter normal CDF, z1, z2, and then comma 0, 1. And then for the left tail, normal CDF, negative 999. Notice that I'm using negative 999 for representing negative infinity here. Notice that I'm finding area from the left all the way up to z. So here on the left hand side here, this is a negative infinity here. So we just want to add some big negative number to represent that. So we use negative 999, right? And over here to find area to the right tail, meaning that area or everything from the right up to the z right here. And notice that my lower bound begins with z, but my upper bound is at 999. Again, I'm using 999 as the upper infinity symbolic for the z-score. So we know that since z-score within 3 standard deviation is already 97.5%, everything outside of 3 standard deviation is pretty small. So 99 pretty guarantees that the area is close to under anything on the right tail of 999 is approximately 0, right? So those are 3 different steps to calculate area in between, right? Here, from left to right. or on the left tail, on the right tail. And those are the calculator step for it. And the 3 here. All right, let's do some practice. Okay, so find the requested probability, or notice I use probability here. Again, it could be, say, area, same thing, for the standard normal distribution, and sketch the graph area. Standard normal, again, remember, and normal mu equal to 1, standard deviation equals 0. Mu equal to 0, standard deviation equal to 1. So let's do it. So we have, I'm going to draw the picture. This is my mean. Mean is 0. Let me write in the middle. Mean is 0. Standard deviation equal to 1. Okay, let's draw the picture. I want area Z less than 2.3. So 2.3 should be on the right hand side of Z on the mean. So right over here. Z 2.3. I want to find the area on the left. So I'm going to shade the region, everything to the left. Notice that left tail, and so I'm looking for the probability that Z is on the left of negative of 2.3. So now let's remember, we say using a calculator, I could do normal CDF. Normal CDF, and think about my lower bound here. Again, I'm going from negative infinity all the way up to 2.3. So for the negative infinity, we say use a big negative number. I said negative 999. And then my upper bound in this case here is 2.3. And mean is standard deviation is 0, 1. Right? Mean is 0, standard deviation 1. So enter that in your calculator, you'll get the answer. So that is approximately, let me do 4 digits, approximately 0.9893. Okay. And I'm going to do that a bit in the calculator later. So let's do the second case. I want greater than 2.3. Again, my mean is in the middle here. Now, instead of doing to the left tail, right now I'm going to do the right tail. So this is 2.3, greater than, meaning that I want the area on the right tail, right? So again, I'm using my calculator, normal CDF. And my lower bound in this case here is, I'm starting, again, think about your arrow here. Right? I'm starting from the lower bound, the lower side, and from 2.3 all the way to positive infinity. So I started at 2.3, my lower bound, and then my upper bound is a big positive number, so 999. And then I can mean 0, standard deviation 1. And enter that in your calculator, I'll get approximately 0.0107. Notice that if I would add the A and B together, I'll get the total probability of 1. Because 1 said left of 2.3, B is right of 2.3, so total together I should get 1. Right? That's 2 cases. Now let's do the third scenario. Between 2 numbers again. Now again, I'm standard normal. Z is given, so standard normal 0, 1. Mean 0, standard deviation 1. Negative 1.3 should be on the left of the average, which is somewhere here. 1.3, and then less than 2.3 somewhere here. It should be a little skewed. Again, I'm drawing approximate here, so 2.3. I'm looking for the area in between, so everything in between and what we're trying to find. And you can even using the little red arrow again, I'm looking for area from left to right. Now, again, I'm drawing my calculator function, normal CDF. Notice now my lower bound is negative 1.3. My upper bound is 2.3, which means 0, 1 still. Once I enter that into information in my calculator, I will get the answer. Now, let me show you how it's done in the calculator. All right. So let me do this. So first, I'm going to turn it on. Okay. Once it's done, go to set vars is right here. So I'm going to go to the distribution. So I'm going to second vars. Normal CDF is second one on the list here. So normal CDF. Now on your calculator, notice that the lower bound is default to negative 1 to e to the 99. Basically negative 99. Now putting negative 99, negative 999, or 9,999, negative 9,999, you're not going to give any different answers here. So I'm going to clear, just put it in what I want. So if I want to do A, I say A is left tail area. I'm going to enter my negative infinity, which represented by negative 999. And then 2.3 and 0, 1 is default here. That's a standard normal. So I'm just going to put it in. So negative 999. Upper bound is 2.3. and mu is 0, standard deviation 1, that's the fall. Okay, and I would have a probability of, notice, approximately 0.9893. Right, so that's the first case. Now let's do the part B, greater than 2.3. I will do second vars again. Go to number 2. Now notice that now my lower bound to positive infinity is the lower bound is 2.3. Now clear it, I enter 2.3. My upper bound I put 9999. Again, you can put as many digits as 9 here, doesn't change your answer. I'll just put one more digit so you see that. All right, so enter here, and I will get 0.0107 here, okay, which is what we got here, right? So the third case, let me do it. Second vars, go to normal CDF. So and notice that my lower bound here is a negative 1.3. My upper bound here is 2.3, and mean 0, standard deviation 1. Just enter that in your calculator, and you get 0.8925. Approximately. I'm round to 4-digit for probability here. This concludes our little mini review for finding probability or area under a normal curve, given z-scores already. So now let's review how to find z-scores. Okay, to find z-score, the calculator function is inverse norm, right? Inverse norm of the given proportion. You know what? On the given proportion, which is on the left of z, proportion that is on the left of z, and the mean standard deviation. Again, given z, I know my mean and standard deviation here, that is 0 and 1. My mean is 0, standard deviation 1. That's going to give me probability of x less than z. Notice that could be less than or less than equal to, doesn't change the case here. I can put an equal sign here, and my answer will still be the same. Notice that for continuous case, less than a number, less than equal to a number is exactly the same answer. Because we say in a continuous case, probability exactly 1 is close to 0. So herefore, we don't really care for whether you have an equal sign or not for the continuous case, right? So let's do some examples. So A, find a z-score so that the area to the left of z is 68%. Again, I'm going to put my mean and standard deviation first. Standard normal means 0. Standard deviation is 1. I want z left is 68%. Right. Left 68, meaning from negative infinity up to z, going to give me 68%. So let me draw it. Again, that means it should be more than half. This half is 50%, so more than half. Let me rewrite it. Somewhat make sure it's 0. So more than half should be on the right of 0. So I would say over here, and my goal is to find this value of z. Right, z is equal to what? That's what we're trying to find. Right. So on the left, meaning that I'm going to show you the area on the left. So the total area here is 68. Oh, let me use some space. Write a 68 here. So this is given to me that is 68%, or 0.68, you want to use decimal form. So that's a probability here, right? So we say to find the score, I'm going to use the calculator again. Calculator function is inverse norm. So I always want to write a step out, inverse norm. The given area on the left of z is 0.68. And mean standard deviation is 0.1. And put that in your calculator, you'll get an answer. So let's do that one, right? So let me clear it. Okay, so on your calculator, go to go to distribution again, which is second vars. Notice that in number 3 is inverse norm. So I could just do number 3. And area given on the left here is 0.68. And 0.1 is my mean and standard deviation for standard normal. And that is approximately 0.47. Okay, so notice that for z-score, I keep 2 digits, 2 decimal place. Now let's do one more. B, find the z-score so that the area to the right is 1.2. Again, it's very important that you actually draw the normal curve and label it, so that way you avoid any confusion what you're trying to find. So let me draw it. So I want to look for the z-score so that the area to the right area to the right is 1.12. Okay, I want area to the right is 0.12, so right telling me that the right tail area is 0.12. Again, I could even label like this. I'm given that this area here is 0.12. I can shade it. The region represent the 0.12, and the question asks me look for this little z-score here. Z is equal to what? That's what I'm trying to find. Again, if the right tail area is 0.12, what is the left tail area? Again, to find that is 1 minus, so meaning from here to here, what is that equal to? The total area is 1. Total area under the normal curve is 1. So to find the area on the left tail, I will just do 1 minus 0.12, which give me 0.88. Right. So now I'm going to put in my calculator. I'm looking for the z-score that separate the bottom 88% and the top 12%, basically. So that's a z that I'm looking for. All right. So using the same function, inverse norm. The area on the left is 0.88. Again, I always put on the left. And then my mean and standard deviation is 0.1. And enter that in your calculator. We'll get z is approximately equal to 1.17. And that's my z. Okay. So again, draw the picture first and then write it, figure out exactly what you're trying to find. That's part B. Part C. Find the z-score that separates the middle 80%. Okay, so the middle 80%, let's draw my normal curve again. The middle is 0, mean is 0, standard deviation 1 for standard normal. Another score in the middle is 80%, so middle 80%. And this is, in the middle is 0.8, 80%. And the question, and the shade that represented by the area between these two numbers here, 80%. And I'm trying to find the 2z below. So this is z1. And that is z2. And that's what we're trying to figure out here. Z on the left and z on the right. So again, if the middle is 80%, I want the middle. If it's middle, that means it's symmetrical here. On the left area should equal to the right area. So the left area, right area add together are going to be 20%, because 0.2 plus 0.8 going to give me a 1, which is 100%. So I'm going to 1 minus 0.8 going to give me 0.2. 0.2 divided by 2 going to give me 0.1. So each tail here is 0.1. Into the area. So I'm going to find z1 first. So z1 is equal to inverse norm. Okay, I want to put the area on the left of z1. On the left of z1 is 0.1. So I enter 0.1. And mean and standard deviation are 0.1 respectively. So enter that in your calculator. We'll get a negative 1.28. Okay, so that is z1. Now let's think about, since it's symmetrical, the area on the right tail should be positive 1.28. Or I can also just using the inverse norm to find that answer. Okay, if let's say I want to use inverse norm again. Well, to use inverse norm, I need the area to the left of z2. Let's think about it. On the left of z2, meaning that from negative infinity all the way up to z2. Note that the middle is 0.8 plus 0.1, so the total here should be 0.90. So if I want to use inverse norm, I could just put it into a calculator. Z2 equal to inverse norm. The total area on the left of z2 is 0.90. And then my mean and standard deviation is 0.1. And we know that the number should be 1.28, right? Because it's symmetric. So let's just verify that with my calculator. All right, so let's do it. I'm going to do the part B and C in calculator again. Okay. Okay, let's do B in calculator again. So second vars, going to go to distribution, look for inverse norm, which is number 3. Now the area on the left for B is 0.88. Okay, and 0.1 is default, so I'll put enter, enter. And then I'll get z-score, which is approximately 1.17. All right, let's do C. Let me clear that one out. C. So same thing. So second vars, number 3, give me z-score. Now first, let's do Z1. Z1, the area on the left of Z1 is 0.1. So 0.1. Okay. and that's negative 1.2a approximately. We say by symmetry, we know Z2 should be positive 1.2a. Let's verify that. So second verse, number 3, area on the left of Z2 is 0.9, and mean 0, standard deviation 1. Notice that I should get positive 1.2a. So again, that's the area of finding z-score under a normal curve. Let's do another example. Now this is special notation here. So when I say z of alpha, the alpha here is a score, so the alpha is given in the proportion to the right of alpha, right? The right hand side. So let's do an example what that means. So I want to find z of 0.05, meaning that let me draw it. So my standard normal with mean 0, standard deviation 1, right? So z of alpha, area on the right hand side, right tail is 0.05. So that's a very small area, and that is z. And area on the tail here, 0.05, we fall into this area, 0.05, the tail, right? So, okay, and question asked me, look for this z. What is this z equal to here? And that's what we're trying to find. So if the top is 5% or 0.05, the one all the way from the left, the total on the left, from here to here to z, from left to z, will be 95, so 0.95. Right? So again, to find that z, I could just enter my inverse norm. Bottom area to the left of z is 0.95. And mean 0, standard deviation 1, that's standard normal, and enter that in my calculator. Okay, so I say second distribution. So number 3, and on the left is 0.95, mean 0, standard deviation 1. I enter that, I get 1.64 approximately. Okay, so 1.64 again. That means this line over here, the score that separates the bottom 95% and the top 5% is by 1.64. Right? So this is finding z-score here, the positive scenario here. Below here, I have some extra practices. If you like to try them, I would suggest you pause the video and try it yourself. Okay, I hope that you have given it a try already. So now let's do, let me go over it together. Again, this is standard normal, mean 0, standard deviation 1. I want to find the probability that z is less than 1.46. Again, let me label it, always draw a picture. And sigma is 1. And I want to find the z-score, the left of z less than 1.46, positive 1.46, meaning that's on the right of the mean. So let's say 1 here. So say this is 1.46, and that is my z. So the area to the left, that's what I'm trying to find. You can even put a little question mark here. That's what you're trying to find. And okay, again, I'm looking for probability or area. So therefore, I should use normal CDF. So write it down, normal CDF, lower bound, upper bound, mean, and standard deviation. Since we're looking for the left tail area, so I would put negative infinity, which is negative 9999, comma, 1.46, comma, 0, comma, 1. That will give you a calculator function. So once you enter that in your calculator, you get approximately 0.927a. All right, let's do the second one. Second one, I'm looking for area, probability or area that's greater than negative 1.5a. Again, that z-score is greater than negative 1.5a. We know that in the middle is 0, which is the mean, greater than negative 1.5a. Negative is on the left of the 0. So we'll say negative 1.5a. I'll put it right here. So negative 1.5a. Area to the left greater than, meaning one area on the right tail. So I'm looking for this area. So let me show you the region of interest. So I want everything here. Right? I'm given my z already. I'm looking for the area. Right? So to find area is normal CDF. Lower bound is negative 1.5a. Upper bound is positive infinity, which is 9999. And you could use that to represent it, then 0, 1. Okay, so once you enter that in your calculator, you get approximately 0.9429. It kind of makes sense. Notice that that's more, have to be, more than majority of the total area here, according to my curve. You can actually see that here. All right, let's do the next one. Now I want to find the area between 2.4 and 3.1 here. Now instead of using x as distributed z, right? Because if we're talking about a normal z curve. So I want to find the area between negative 2.4. Let me draw it. So again, the middle is 0. Let me put a red here. This is 0. So negative 2.4 should be on the left. Negative 2.4. Positive 3.1 should be on the right. And I want to find the total probability of the total area in the middle. And I'm going to show you my region of interest. I'm looking for this area. Now I can just enter into my calculator. Lower bound, upper bound, mean 0, standard deviation 1. So on your calculator, again, you're going to put normal CDF. In this case, my lower bound here is a negative 2.4. My upper bound here 3.1. And we'll say standard normal have mean 0, standard deviation 1. And enter that in your calculator. And you get approximately 0.990A. Right? So that is my finding probability. And now the next part again is a practice for finding a z-score. I want you to pause the video and give it a try. All right. So once you tried it, you can check the answers. So hopefully you've done your practice, and let's go over it together. Okay. Find the z-score if the probability to the left is left of z is 0.43. Okay. Again, like I'm talking about z, so standard normal. Mean 0, standard deviation 1. So left is total area, again probability meaning the same as area. So area under the curve on the left of z is 0.43. That's less than half, so I'll have to be on the left of the 0. So over here, I'm given that the area here is 0, this is 0.43. And the question asks me to look for this z-score. What is that equal to? Right, that's what we're trying to find. So again, I can show you the region that represented by the area. So I'm looking for that z-score. Again, to find z-score, we say we use the function of inverse norm. All right, so let's write that. So inverse norm. Area on the left is 0.4 of z is 0.43. I enter 0, 1, and into your calculator, you get your answer approximately negative 0.18. Right, so this is approximately negative 0.18. Right, so that's the first case, and my z-score, and that's what I'm trying to find. Now notice I have to make sense because on the level 0 have to be negative. All right, let's do this number 3. Number 3 is z of point alpha. Alpha is 0.15 here. Again, this is special notation. This is your alpha. Alpha referring to the right tail area is 0.15. So let me draw that. So this is 0, this is the middle. Area on the right tail is 15% of 0.15. So let's say telling me that this area here is 0.15, and your goal is just find this score. Right? You're trying to find the score that separates the bottom from the top, bottom 85% to the top 15%. So if the right hand side is 0.15, the one on the left must be 0.85. Because they add up to 1. Now to find z-score, we say inverse norm, the function. Inverse norm. Area on the left of this z that I'm interested is 0.85. And mean 0, standard deviation 1. Right? Put that in the calculator. It's approximately 1.04. Positive, because on the right, 1.04. Right, so and that is the z-score. The separates the top 15% from the bottom 85%. All right, let's do one more. Find the z-score that separates the middle 56%. Okay, the middle, let's draw it. So if this is the mean here, middle, I'm going to draw two things represent the middle. The middle here is 56% or 0.56. Okay, that is the region represented by the area. Now the question asks me to find the z1 and find the z2, right? That's what we're trying to find. We want to find the z-score to separate the middle 50% from the rest. Okay, now we find the middle, I need to find the two-tail. So first, I need the 1 minus 0.56 and then divided by 2 because the two-tail area should be symmetrical. So 1 minus 0.56 is going to give me 0.44. Half of 0.44 is 0.22. So this is 0.22. This is 0.22. Right, symmetrical here. Now I'm going to find my z. So we say z1 is equal to inverse norm. Area on the left of Z1 is 0.22. Mean zero, standard deviation 1. And put that in your calculator. You get a negative, approximately negative 0.77. Alright, and by symmetry, I can say Z2 is also should be, this Z1 should be a negative, right? Z2 will be a positive one. Z2 is positive 0.77. So those are the two Z-scores. Again, you can double check that with your calculator and get the answer. So let's do number 4 again using a calculator. Okay, first let's find Z1. So second vars. Number 3, inverse norm. Area on the left tail of the Z1 that I'm interested in is 0.22, 0.22. And 0.1 is mean standard deviation. Okay, so approximately 0.77. And by symmetry, we said on the one on the right hand side should be positive 0.77. So let's verify. So second vars, number 3, area on the left of Z2. Notice that I want the total area on the left of Z2, not 0.22 here. It's a total of 0.22. Let me draw it. Let me draw from here to here. All the way here is 0.56 plus 0.22. 0.78. So I'm going to put it into the calculator. So 0.78, again 0.22 plus 0.56. And now 0.1 is my mean and standard deviation, and 0.77 approximately. Alright, so this is complete the review for standard normal curve and Z-score. Now in the next lesson, I'm going to go over other normal distribution, which is 7.2. Alright, thank you for watching the video. I'll see you next time.